Hello YouTube, Spazzy here. Wait, wrong YouTube channel. Not Spazzy. Spazzy's not here. Completely different YouTube. Uh, Hello everyone. Here. Ooh. Alright. Uh, how you guys doing? How's life has been? How's life treating you so far? How has life been treating you? Has it been good? Doing well? I hope so. Alright, so here here's what we're gonna do today. I realized that I have not pushed my previous code. I said I was going to push it, and I didn't do it. Classic move. That's a classic me. Do that all the time, which is unfortunate. So all right, cool. I'm just setting up a few things. Sorry. Give me a sec. Apologies. Okay. So, hey everyone. How's your day been going? How's your week been going? Hope it's been going well. So last time, what we did is we went on, what did we do last time? Did we get to image views? Did we finish image views? Yeah, be sure we finished image views. Let me check. With the surface here? No, that's swap chain. We did window surface. We didn't get that far. And I believe we only did half of this, no? Presentation, startup. Yeah, I know we did this. So querying for presentation support. Yeah, we haven't done. If I haven't done presentation support, I don't think. Yeah, we haven't done that. Sorry, I'm just checking my email. 1 second. I've done this. Problem one. Da, 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 da. Google, can you like not? Can you please like not? Please? I'd really appreciate it if you can just not. Right? That would be fantastic. Thank you very much. All right. Do sound check. Test. 1 2 3. 1 2 3. Test. Check. Recording. My mic. It's 100%. Like that, so you can hear me all well, nice and clear. Sorry, I had to do it. Can't help myself. I just myself. And to do it. I had to do it. Alright, you can skip like the first 3 minutes of the stream. You're watching this on YouTube. Apologize. Alright, so here's what I'm gonna do. I'm gonna go to GitHub, not GitLab. I'm gonna go to GitHub, seeing this is an open sourced, readily available engine out there. Let's star my engine. I'm gonna give my engine 1 star. You know, I deserve a star, alright? Alright. I think it's in my right. Alright, so what do we do here? Let's see. Added surface extension to Vulkan instance. All right, so we did that. What else did we do? Added physical device. Added added logical device. What else did we do? Added graphics queue family. Added Win32 surface. I think that's about it. There you go. Added devices and surface and 132 surface. All right, stage all of this lovely stuff, commit, push it right to dev. That's where we want it. Cool. Let's merge with main. Go merge here, merge dev into main. Yes, please. Main. Done that. That is absolutely fabulous, as they say. All right, switch to dev. My friends are playing Battlefield 1, and I'm doing the Lord's work. And the Lord's work needs to be done. If you're not familiar with the Lord's work, it's getting Vulkan up and running. Right? Like this. Beautiful. Absolute magnificent stuff. Yes, yes, indeedio. Indeedio, sir. Okay, so destroy surface KHK, KHR. Not the KKK. KHR. There's a difference. Okay, so the JLFW, so he does this stuff, okay, we're done all this. Okay, so querying for presentation support. Although the Vulkan implementation may support Windows system integration, that does not mean that every device in the system supported. Therefore, we need to extend the iDevice suitable to ensure that the device can present the image to the surface we created. Since the presentation is a queue-specific feature, presentation is a queue. Okay, so we got a graphic queue, in a graphic or in a queue family. And now we need to check in the queue that it supports presenting to a surface. The problem is actually about finding a queue family that supports presenting to the surface we created. Oh, so it's an entirely different queue family. Interesting. Very, very interesting. Very intriguing. It's actually possible that the queue families supporting drawing commands and the ones supporting presentation do not overlap. Therefore, we need to take into account that there could be a distinct presentation queue by modifying the... Hold on, I was spacing out while reading this. It's actually possible that the queue families supporting drawing command and the ones supporting presentation do not overlap. Therefore, you have to look into account that there could be a distinct presentation queue by modifying the queue family structure. Okay, makes sense. Mecha Shenshato. We'll next modify the find queue families function to look for a queue family that has the capability of presenting to our window surface. The function to check for that is vk get physical device surface support khr. Could you make it any longer? Yes, they can, and they will. Which takes the physical device queue, which takes the physical device queue family index and surface as a parameter, and add a call into the same loop. Okay. All right. So basically, we take the device, which is our GPU. We give it the surface, right? The lovely surface, and we get the support. The magnificent support. All right, cool. Let's do that. Let us do that. Okay, so without copying code, because I don't copy code, okay? I've never done that. I never will. I don't know what you're talking about. This has to go up. Why Windows? Why would you scroll all the way up? Like, why? Why Windows? Why Windows? Why? To do. Add validation lever. Validation layers. So cute. Sure, we'll do that one day. One day. Where do you want me to add that, brochacho? Brochacho. Oh, I assume here, yeah? Because we're checking for the search for graphic queue family and get index number. And there we go. Indices present family. Yeah, so graphic index. So hold on, this requires the surface, and the surface is being done here. So actually, technically, we have to do this down there. We can't do it over here. All right, so next. The next part would be to do the following. Okay, so why does this have less characters than this one? What do I do? There we go. All right, what are we doing here? Search for presentation support or query. Let's do query. Let's do what I keep saying. Query. I think I spelled query. I assume that's a query. Done a lot of queries. Put this a little bit like that. Make sure this is the same size as this. Copy, paste. Excuse-moi, senors. Okay. All right. Here we go. Here we go. So here. BK get BK get physical device surface support KHR. Okay, which would take the physical device. It would require the Q family index, which is somewhere. It is definitely somewhere. Q family count, graphic family index. VK the surface, obviously. And then a boolean, whether it's be supported or be not supported. So boolean present support. It's also better support. Does graphics you support presentation? And I realize this is a long ass variable name. Graphics queue support presentation. You know what? It's fine. It's not like anyone is ever going to use this variable ever. It's all good. It's all good in the hood. You know the hood? It's all good there. Oh, it has to be VK. Okay, fine. VK bool 32. There, are you happy? Jesus Christ. Also returns a result. Results like that. Do that. Vulkan 132 surface. Or no. Vulkan graphics queue supports presentation. Support presentation. To surface. Fail to query for presentation support. Failed to query for presentation support in graphics view. Support for failed to query for presentation support in graphic view. Graphic queue. Sure, why not? Why not so? Why not so? Alright, let's see if this work. It's gonna fail. Failure supports the presentation surface. Oh wait, no, that does not what that's not what that means at all. Oops, my bad. This should be here. Vulkan graphics view support presentation. Querying for Vulkan physical device surface support is successful. Google, would you like to fix all my spelling mistakes? Thank you, Google. I really appreciate you. Alright, let's run this one more time. Alright, querying for vehicle support is successful. Vulkan key support presentation to surface. Alright. Else Vulkan graphics queue does not support presentation to surface. All right. So that is done. So that's very likely that these end up being the same Q family after all, but throughout the program we will treat them as they were separate queues for a uniform approach. Nevertheless, you could add logic to explicitly prepare physical device to support drawing the presentation. And so hold on, this only returns the queue. This only returns whether it's support or not. How do I know? Okay, well, okay, the graphics, okay, it's fine. Create the presentation queue. Hell yeah, baby. Let's do this. BKQ. Oh no. Oh no. I did it again. Oops, I did it again. Presentation queue. Presentation. I feel like I'm spelling this correctly, but you know what? Nevertheless, I would love to double check. Next, we need to have multiple VK device queue create info structure to create a queue from both families. An elegant way to do this is to create a set of all unique queue families that are necessary for required for queues. What in the flying fuck are you saying? Why are we doing this right now? Excuse me, senor. What the fuck are you saying? Next, we need to have multiple VK device queue create info. Why? Struct to create a queue from both families. Now, the way to do this is to create a set of all unique all unique queue families. Okay. Queue family indices. Alrighty. And then he's making a bunch of VK device queue family info, create info. Unique queue families. And present queue priority. For every queue family in queue families, VK device queue create info. Type create queue info. Queue family index. Queue count equal to 1. Okay, and modify VK create info to point to the vector. Create info. If the queue families are the same, then we only need to pass its index once. Finally, add a call to retrieve the queue family handle. Oh, Jesus Christ. What the fuck are you doing, my friend? This is very confusing. I am very confused. Oh, Jesus. Why do you keep doing that? Fucking Google Chrome. Alright, hold on. Hold the fucking on. So, okay. We get the graphics index. And so we create a Vulkan logical device, which he wants me to make another fucking logical VK device queue create info. VK device queue create info. She wants me to create another fucking queue family. Queue family, queue family. Okay, he's making 2, and then looping through all the queue families and unique queue families, which are the 2 indices of ours, and then creating a logical device for every Q family. If the Q families are the same, then you only need to be past its index once. Finally, add a call to retrieve. Where are you checking if they're the same? How fucking interesting. Yes, can I see your splendid C++ code? Ow! My arm. I would really appreciate you right now. Okay, he's creating the instance. Fantastic. He's doing some bullshit. Okay, here, create logical device. He's getting all the indices, creating a Q family. So he's essentially modifying this. What is he calling this function? Create surface. He's creating the surface way up top. Way up top. He's creating the surface way up top, which makes sense. I mean, we really don't need to create the surface over here. Because when we query for presentation support. Okay, so this code has to be swapped. Motherfucker. Alright, buddy. I'm warning you. I'm letting you know right now that you're starting to piss me off. Alright, buddy? Alrighty, buddy. Alright. Alright, after I create the instance, do I need physical device here? No. So after I create the instance, I can immediately create the surface. Or check for surface creation, which I do. Good sir. Good sire. Good sire. Good sire. Alright, so we do the deed, and the deed has been done. So I create my instance, I create my surface, and when I create my physical device, then sure, I create my physical device. There's two spaces here. I create my physical device, and then I search for my Q family's index number. And then I query for presentation support. Presentation support requires a graphics family index. Okay. Which I find over here. So before the creation, so this has to be above. Oh, Jesus. Take the wheel. Please, Jesus, take the wheel. Take all the wheels. All the fucking wheels. Take the wheels like there are no other wheels in the world. In the world, there are no other wheels. The wheels are full. We're full of wheels. All the wheels in the world, all full. Cool. All right, so we have a Q family count. This is my few family count. My full family count. My family clanty flaunt has a family clounty clount. Because the floofly clafty clount surface, and he does the physical device, and he finally does the logical device. All right, so we are in the same order, which is fantastic work, to be honest with you, sir. Good sir, beautiful sir. 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 Good sir. All right, so this is our physical device, which physically exists. So that's physically beautiful. And then we do the family count. Then we have a vector of Q family properties. Q family. But okay. Device creates. Okay, so this PK create device, logical device. Logical device create info. Oh, Chichacho. Okay, so here's the thing, lovely people. Um, okay. So here's the thing. According to what he's doing, he's creating the logical device. Once, right? Alright, create info. PQ create info. So this is the data and this is the size. PQ. So when we finally create our physical device, sorry, logical device, I meant here. When we create when we finally create our device, we have to give the creation info or create info. And then VK get device Q for the graphics. And then he does the same for the Alright, I see what he's doing. I understand. So here's what this lovely man is doing. He is currently creating VK device Q create info, a list of them, because we want to check for graphics family index. But he gives Q family. So for each Q family in unique Q families. And he finds the unique Q families. From the present family, which he finds over here, which currently, unfortunately, I'm currently a bit oh, we're doing this code in here. Okay, so VK device queuing family property. It does. And then Q family properties. Then for the Q families, for all the Q families, we check if we have a graphic bit. If we do, we assign it. Next, we check if that graphic bit, it would check if the Q family supports, or this surface and this Q, if this Q family and using this surface supports presentation support. If it does, then we assign it. Otherwise, we continue to the next Q family. That's how I should have done it. Which makes sense. Makes total and very much macho senso. Macho senso. Macho senso. Macho senso. Big senso. Close. Small senso. Okay, so this code, do you see this code, lovely? Sire, good sire, do you see the code? The code, the big code. The big code is under itself. That's where the big code is. Sire. Sire, sire. Where is the big code, sire? Sire, sire. Where is the big code, sire? The big code. The big code, sire. Sire, the big code. Where's the big code? We need the big code, sire. I'm telling you. The code is important. Very, very important. As important as it can impotently be. Impotent. Impotent. Very important. Like when thing is impotent. Okay. Okay. And so in here, right, we shall check instead of graphic queue, right? Gonna do I. Then we're gonna check for all the family queues. So if graphic, if that is bigger than 0, it's bigger than -1, and that is true, I would like you to break out of this loop. Vulkan found presentation queue. Vulkan failed to find a presentation queue. And this does queue support presentation. Okay. Like that. Okay. And so we have our family index. Int presentation family index equal -1. So I actually just delete all of this. I'll do that for now. Beautiful. Alright, let's run this. Uh, where? Oh, well. Well, obviously. Alright, so let's see this. Let's see this lovely stuff. Okay, so hello. I really can I just make this always big because genuinely I cannot see for the life of fucking me. We always do like 36. If I restart this will be 36. If I stop it, let's play. Fuck yes, baby. Alright, so hello engine. Window created successfully, Vulkan extension retrieval was successful. Vulkan extension retrieval was successful. Why does this do twice? What kind of extensions are we retrieving? That is the question. Why in the fuck are we doing that twice? Oh, okay. Fine. Fine. Why are they need to do it twice? Uh, or why not? Okay. So Vulcan trivial extension, okay. What's 11? There's the fucking number says 11. We don't need that anymore. Or we can just type total extensions found, total extensions found. Then just do that. Total extensions found. Extension property. You know what? I would really like to see all those extensions. Um, that, um, supported extensions and are. We can just do that. Okay, nice. I can see all the supported extensions. Are that we can make this a little bit prettier, you know. Um, out that SCDNL. That would be very nice, senorita. There's what's this space here? Also, let's do /n/n /n/n. Yeah, this will be a little bit nicer now. Okay, maybe too many /n's. Page spawn slash index. And alright, let's see this baby. Okay. Vulkan, total extensions, fan 11, support extensions. Vulkan server has been created successfully. Device count 1. Alright, so what in the fuck is device count? Device count, physical device. Physical device count found is total physical device count found is, and just put that to capital T. Physical device is a discrete GPU. As well as physical geometry. Success index is screening for Vulkan physical device. Surface support successful. Graphic family found index 0. Presentation family found index 0. Logical device initialized successfully. Logical device initialized successfully. Alright, so after we search for our graphic Q family, graphic Q and presentation Q family and get their index numbers. Which we did there. Alright, so we got both of their indices, and now we need to do this bullshit. Oh god. Oh, I feel like procrastinating. I feel like procrastinating so much right now. Not even funny. Alright, let's finish this. We have so much more to go. So much more to do. At least we'll finish the window surface, and then we have to start the swap chain. How much or how big is the swap chain? Fuck. Big. Oh, fuck me, it's big. Holy fuck, it's very big. Oh, the swap chain, ladies and gentlemen, it is massive. It is very, very massive. It is very big. Very, very, very big. Very, very, very big. Very, very big. And you know what they say about big things, right? I don't know what the fuck they say about big things. But they exist, apparently. Alright, once I found the indices, hmm, in total, Q family is equal to -1. And then -1. Then we increment this by 1. Then we increment this by 1. Okay. Okay, so essentially here what I'm doing is we need to check whether we have whether the graphic Q family, right? We need to check whether we need to look for a graphic Q family. Once we found it, we increment as all Q families we have, because we could have more than one Q family. Once we found the graphic Q family, we need to search for the presentation Q family. Once we found it, we increment the total Q families by 1. And then here we make sure that once we have both of them, once we have the graphic and presentation Q families, once we have both of these, we get out of the loop, and then I check, and then here I just print the indices, the index numbers. I mean, why do I do this? Why not just do it in here? At I, Q family at I. Then family also I. Okay, so what I'm thinking here is once we find the Q family at I, and then we find the presentation family at I, right? Once we do that, so here, if we couldn't find the Q family, then I would like to do this. It's a fail find graphic family, and then do the same thing for presentation 1. So to our messages, so if we found the graphic family, then great. If we found the presentation family, great. Then I need to make sure if we found both of them, we exit out the loop early, and then I check. Did we find the graphic family? If not, we say failed and we return. If that goes well, then we check this. If the presentation family index is not -1, which means if it's equal to -1, which means we failed to find this. So we exit. So we exit both these. However, if both of them are the same index, then we say total unique or total Q families is 1, because they are the same Q family essentially, both of them. So we don't need to do any kind of magic here. So if I press play, this should all work as intended, which it does. Which is graphic family found index 0, presentation family found at index 0, right? We found all that. Now we need to do the creation part. Oh boy. All right, let's do the other part. Here we go, boys and girls, ladies and gentlemen. Ladies and gentlemen, I would like to present to you our biggest case from Radio 5, 1992. I don't know what the fuck I'm saying, but don't worry about it. You shouldn't worry about things. You know, if you stop worrying about things, then things will make you... Okay, so I do hear the thing and the stuff. And I gotta be honest with you. The thing and the stuff are important. Okay, so I make my queue, device queue, create info. But he doesn't make one. He makes multiple ones. He makes multiple. VK device. Queue create info. Because he is crazy. He is crazy, baby. He is crazy, baby. Oh. Okay. So he makes a queue of them, and then every time he makes the one, he push it in here. Once he push it here, he submit the stuff and the things. All right. So we gotta do the same thing he's doing. We gotta go and do the same thing he's doing because it's cool. Because he's cool. He's a cool man. He's a cool Spider-Man. Device. You create info. Infos. Because his who because his behold his who what the fuck? Because it's cool. Because it's cool. He is very, 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 very cool. Na 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 na. Sorry about that, boys and girls. I apologize. I do not apologize. Still Q family. Still Q. Tonight is the day we go to the moon. And then we come back from the moon, and then we go to the moon again because we forgot our pants on the moon. Why did you take your pants off on the moon? I don't know why I took my pants off on the moon. I was crazy. I spilled coffee on my pants in the moon. But there is no gravity on the moon. Oh, there is gravity on the moon. Is there really gravity on the moon? Yes, there is a gravity on the moon. Because the moon is the moon. And you can't spell stuff on the moon. Because the moon goes like boom, boom, boom. Thank you, ladies and gentlemen. Thank you very much. I really appreciate your support. And what was the other one? Not pushback. There was another one. I appreciate support out and place back. There you go. I appreciate your support, and in honor of this event, I'd like to thank my parents who stood by side by side for years. I'd like to thank my friends, my amazing producers, composers, songwriters, and artists. I thank you all, and I owe you a debt of gratitude. Please don't play the music. Please don't play the music. I would like to thank my friend Joey, who gave me a falafel the other day. I would like to thank my please no hold on I'm not done. Please I'd like to thank my the guy who washes my car. He washes it very, very well. I'd like to thank the guy on the corner of 55th Street. He's amazing. He gave me a cup of coffee the other day. It was beautiful. And yeah, thank you so much. Thank you for the Grammy. Thank you for all your support. Yeah, so I'll see you. Please wear shoes and pants because Otherwise, you'll spill coffee on you're gonna spill coffee on the moon. You're gonna spill coffee on your pants on the moon. Ooh. What the fuck is wrong with me? That's what Vulcan does to you guys. Don't trust Vulcan. Vulcan is bad hits on the moon. Alright, hold on. Q family index. These are different. These are different. And because they're different, we must give the difference to all the difference. Yes. Yes. What the fuck am I doing? Why am I doing all this shit? Can someone please tell me what the fuck am I doing? I found the moon on the gravity of the moon. I got to the moon. You got to the moon. We got to the moon. I got to the moon. I got to the moon. Moon, moon. I got to the moon. You got the moon. We both got to go to the moon. All right. So here's what I'm thinking. I'm thinking because this needs the correct index. I should put this in an array, or sorry, a queue. Right? I should just put this in a queue. Not a queue, I mean a vector, right? Because we need the index. This queue family index wants the queue index we just found. And so we have two of them. We have the presentation and the queue one. And we have a loop of the total ones we have. So so what I'm thinking here is just like there's no way to make this work really. I mean, there's a way to make this work, but yeah, whatever. So here's what I'm gonna do. I'm gonna do std cout. Not std cout. What am I doing? Std vector 2. Q family indices. Q family indices, which be int h_t. Right. Righto. Righto, bub. Okay. And so just make it an int. Why am I doing this? Dot in place back. I can remove this. Can remove this. Then placed I can remove this, and I can remove all these. Then place back I. Then I can place back I here. Size bigger than or equal to 2. If I equal to because it could be the same I, right? So YouTube keeps giving the message, the audio stream currently is 0 bitrate. How is it 0 bitrate? Google, can you explain that to me? It's not 0 bitrate. What is wrong with you? Are you crazy? Because I think you're very crazy. Whatever. Alright, so here's what's happening, right? I am placing the... Here's what I'm thinking. I have my Q index. I found the graphics one. I push it back into this vector. And then, so this might not happen first, obviously. So if we go here, this might happen first. Okay. So I add this over there. I add this over here. And then bigger or equal to, I get out. So now I could here find, so I think if I remember correctly, I could find more than one queue that supports graphics, right? Like that's a possibility here. How many queue families do I find here? Can you just shut the fuck up for a second, please? I would really fucking appreciate it if you could shut the fuck up. Thank you. Oh, you're still being a little bitch. Alright. Got it. You're still gonna be a fucking little bitch? Yeah, that's right. That's what I thought. Fucking asshole. There are currently 3 queue families, right? It's very much possible that I add the graphic family for the first one, and the second one I add the graphic family, and the third one I add the graphic family, right? So adding the if statement is a bad idea. Let's go through all the graphic families. Oh, sorry, let's go through all the families. Okay. We go through all the families, and we find which one support graphics, which one support presentation. So this supports graphics. This supports presentation. No graphics. This supports presentation. No graphics. This support presentation. So all, you can see 0 supports graphics. 0 supports presentation. 1 supports presentation. 2 supports presentation. I have no way of fucking knowing which one is the representation and which one is the... Okay. 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 Alrighty doodle. Sir, good sir. Good, very good, good sir. Very good sir. Here is what I would like you to do, sir. So here's the problem, right? So graphics, we can find 1 graphic, 2, 3, 4, multiple graphic families. We could also find multiple presentation families. Essentially, the best scenario is to have the same graphic family also supports presentation family. That's essentially my goal, is to find a graphic family that's also is a presentation family. The presentation family and graphic family, they're the same in one, right? That would be the ideal case. The non-ideal case, one would be a graphic family and the other one would be a presentation family, which would mean I have two of them, right? So I can just pick two. Now, the problem is if I add both of these into the same vector, I wouldn't be able to know which one is graphics and which one is presentation, right? Which is not great, because as you saw right now, it says 0 supports graphics and 0 supports presentation. 1 supports presentation, 2 supports presentation, 3 support presentation, right? And so I have no way of knowing which one is which. So what I need to do is make 2 different queues, right? One would be a graphics family, graphics queue family, families, family indices, sure. Graphic queue family indices, and then presentation queue family indices. And so we add all the graphics here, we add all the presentation here, righto. Okay. Once we add both of these, we would like to find a unique one between the two. Okay? That's ideally what I would like to do. So, here's what I want to do. I would like to loop through the graphics queue family indices, graphics queue family indices, and another loop for the presentation queue indices dot size. Here, what I would like to do and find out. Okay. I would like to check int queue family graphic and graphics and presentation queue family index equal -1. Okay, so if graphics families at I is the same as graphics family at j, then I would like to make this equal to graphics family at I, and then break. Essentially what this does, it's gonna find the common find the common index between graphics presentation queue family. Right? I like to do that. If I do manage to find it, then that's great. If not, I need these at the top here. If families dot size is less than or equal to 0, Let's find graph family in BK, okay? If presentation Q family dot size is less than or equal to 0, shut the fuck up. Then we do that. Or if both presentation and this we find something in common. If we manage to find something in common, I would like to say std cout found a Q family that supports both graphics and presentation. And the graphic Q family is supports both graphics and presentation to surface. And L. Okay. And a Q family supports both graphics and presentation surface at index. Put the index in here and get out. Okay. If graphic Q family equal to less or equal to -1, then failed to find a Q family supports failed to find Q family supports both graphics and presentation to surface. Graphics Q family. First rescue family will be chosen, which is at index. We can view the index. First presentation Q family will be chosen, which is at index 0. Is at index 0. Okay. Oh god. Okay. Cool. What's wrong with this code? Okay. Okay, so the graphic presentation is index 0. And the graphic is, I think, 0, presentation 0, 1, 2. So now I'd like to find a common one. We found the common one, which is now index 0, right? And so this doesn't have to run, right? So now unique. That's how you spell unique? I don't fucking know. That's definitely not how you spell unique. Unique Q family indices we'll do, we do this, dot and place back. Okay. Honestly, we won't even see this. Place back this. If unique dot size is less than or equal to 0, then we say failed. Wait. Okay. And then here we do dot place back 0. Place back 1. Oh. And so up until here, it have a unique index of 0. You fuck off, thank you. It should have index 1 and 0. Alright, that works. That was a lot of fucking. I'm pretty sure he did it in a much nicer way, but whatever the fuck, I don't care. I'm doing it my way. Doing it my way or the fucking highway. Alright, if I don't need that, search for a Q representation for index number. What is this for? Where am I using this? Search. Oh, doing it twice. Doing it in here. And find common index between. Oh, let's be. A lot smaller. There. Very much smaller. Dankeschön. Señorita. Okay. Then this goes here. Like that. These guys are tiny. Tiny. Okay. Then here, we create our fucking unique, but now in here, size. Dot I. Oh, hold on, this might be 2. Okay, if it's 2, how does he do it if it's 2? Sorry. So he does the unique thingy. He goes through all of them like a boss. He goes through them. He does this structure. Then you say Q family index is the Q family, which I just did. Okay. There's 1, and then Q priority. Where in the flying fuck is this Q priority? Excuse me, sire. Where is my fucking priority? And then he places back. Once he's done, he does this. I can just fucking do this, bro. Okay. And then He does that. He does the info. He does the info. Q family create Q, EQ. Q family create info count. Info count. He is doing not one, but instead a static. Oh, he's casting it to. Can I just do this? Yeah. Yeah. Can I not do a static cast? I would like not to do a static cast if all possible. I just cast this like that. What is size? I can't. And how can I not use static cast? I don't want to fucking use C++ stuff. And use C++ stuff. Because I'll fucking understand it. Oh, don't need that. Wait, what? No. What the fuck am I doing? I am so fucking stupid. I am so fucking stupid. I am so fucking stupid. And then unique family is the data. Okay. Um, Whoops. Okay, so that's done. Data features 0. This enter validation. Alright. This should all work like a fucking charm. Put a breakpoint here. But really quick cato. This should be 1, so we do this. Right is 1. Next 0. We add this. Done. We give the size is 1. Create infos. Whatever the fuck that is. And it's successful. Alright, so we did that. Vulkan services been successfully. Total device found is 1. Device shared reality. Physical device. Index graphic family found 0. Querying for Vulkan physical device support is successful. Edition family found. Querying for file successful. 1. Successful. 2. Found Q family supports both graphics at index 0. Logic device successfully. Okay. So did all this bullshit. Good. Oh fuck. Oh shit. DK device queue. I have to do this twice now. So we need our graphics queue. Then we need our presentation queue. Well, Sorry, I'm quiet. I'm just kind of focusing here. Plus, it's getting tired and I'm very exhausted. I don't want to fucking send
Presentation.
presentation. Okay. I want to make sure of the spelling. Graphics is... So if we manage to find it, then graphics equal to this. Presentation equal to this. Alright, otherwise... Alright, so I just want to make sure that we have the correct index. So for the graphics, if they're common, that means both of them have the same value. If they're not common, then we'll pick just the first one from here, first from here, and place it like we would. The reason I did all that is because at the very end here, it needs the index. So I have to give the graphics one and the presentation one. They could be the same, they could be different. It doesn't really matter, as long as doesn't really matter. It could be the same, it could be different. Doesn't matter. They're still stored into different variables, which is kind of useful. All right, so that should all work now. Well, that crashed. Presentation is no. Graphics is no. Logical device is no. Why is logical device no? What did I exactly do to make logical device unhappy? Oh, actually do from here. Oh, oops. I forgot to uncomment this line. Alright, there you go. So, found that supports both graphic representations for the next 0. Logical division successfully. Jesus Christ. Alright, so that's done. It's all a bit messy, not gonna lie. It's not the greatest in the world. Okay. Cool. So we did that. Okay. Again, all I really want to do is I have graphics Q family indices, presentation Q family indices, and the unique Q family indices, right? So presentation, sorry, for the graphics, I could have more than one graphics Q. I could have the 0, 1, 2, 3, 4, 5, a million. Presentation is the same thing, could be 0, 1, 2, 3, 4, 5, a million. Or presentation could be 0, nothing, like literally nothing. Graphics could be nothing, right? So I need to find all the ones that support graphics, all the ones that support presentation, and store them in these two vectors. Once I do that, I start and I compare. is there a Q family that supports both graphics and presentation? Is there anything in common between the two? Like, can I have one that has both common and both of them as in common, right? So what I do, I create two variables, and these two variables, I just need them for later on, just so I don't have to do an if statement over here. But anyways, so I create two variables. I say, hey, graphics Q family index is -1 and presentation Q family index -1. The reason I do -1 is just because maybe it's 0, maybe it's 1. You know, when I do -1, there's no way this function is going to return -1. So -1, I know that if it's -1, then something went wrong. 0 is a valid index, 1 is a valid index, -1 is not a valid index, right? So I have two loops, and I check, do these guys have anything in common? If they do have something in common, if they have the same index, then I just push a unique index in here, and I say, hey, this is the unique index. And then I set the graphics Q family to that index and presentation family to that index. So now both the graphics and presentation have the same index, but I put that index in both variables, right? For later on. I need them later on. Okay. However, if I couldn't find anything unique, then that means if I didn't find any unique ones, it's less than 0. Then I just pick the first index from graphics, and I say that's the graphics one. First one from presentation, that's the presentation one. And then I add both of them into the unique one, right? So now, unique Q family indices, it has maybe index 0 and index 1. In here, it is guaranteed to have both index 0 or both index 1 or both index 2. It doesn't matter. The point is both the presentation and graphics share the same index. In here, they share different indices. Cool. Now that they share different indices, and I know that, and for example, I store graphics and presentation, here when I go and get my logical device or get my Q, right? I need to figure out which one has the graphics, which index is the graphics, which one is the representation. Like, if we go in here, then they are the same, right? If this is successful, then both the graphics and the presentation are the same. However, if it's not successful, then they're not the same, and I need to figure out whether they're the same or not. So what I do is I create the graphics and presentation indices, like in two integers. I set them here to be the same. I set them here to be different. Whichever one it is, I will get the one correctly here. And I just do that so I can avoid the if statement that I had before, the ugly if statement, which wasn't really nice, and it was a little bit error prone. So now it's just fine. Not the prettiest code, not the greatest code. It works and it does the job, which is fine in my book. He did it very differently. He did like sets. He used the set unique families, and then use like a set somewhere in here. I don't know where to get that. Static cast. I don't know. He did something somewhere. But anyways, so that's how I'm doing that, which is great. Which means now, fucking done with this. Yeah. Cool. We're fucking done with this. Anyways, so now that we're fucking done with this, which is great, now we can move on to swap chain. Man, do I really want to do the swap chain now? How long have we been going? How long has this been? An hour and 44 minutes. Holy fucking tits. Okay. How big is the swap chain? Oh man, I see extensions. I see stuff. Need to pick the swap chain format. Mother chot. Bro, I really don't want to fucking do a swap chain. Image views. Image views is not as bad at all, actually. Image views is compared to swap. Like, compared to anything, image views is fucking done. So we just need those two. Graphics, and then we can, oh my god, then we can jump to cursor swap. Actually start doing this. And then do the shaders. Fix pipeline, render passes. Conclusion, when do we draw a triangle? We have to do a frame. Alright, there's a lot. Oh my god. Should I just pull through and just do another, do the swap chain? I don't know if I should go with that. Problem is, I don't want to start this and stop in the middle. But I know if I stop now. Okay, I'll stream tomorrow. I promise. No, I have to stream. What I was saying is, if I stop now, I might not stream for another like month or whatever, right? Because I only stream when I'm in the mood. So, but no, I should stream tomorrow. I should definitely stream tomorrow, and just get the swap chain over with. Or should I just take a fucking break? I'll take a small break and then do the swap chain. I don't know what to do. I swear I don't know what to do. Maybe I should take a break. Just a small break. Alright, here's what I'm gonna do. I'm gonna take a small break. Okay. And when I'm done, let's 5-minute break. Watch a YouTube video or something. Just relax for real quick. When I'm done, I'll continue. Yeah. Alright, let's do that. I'll be right back. Alright, ladies and gentlemen, I'm back. Let's do this. Let's do the fucking swap chain, because there's nothing going in my life better than doing the fucking swap chain. The fucking swap chain. Okay, cool. Vulkan does not have the concept of a default frame buffer. Yeah, I know. Hence, it requires an infrastructure that will own the buffer we will render to before we visualize them on the screen. This infrastructure is known as the swap chain. Yeah, baby. And must be created explicitly in Vulkan. The swap chain is essentially a queue of images that are waiting to be presented to the screen. Our application will acquire such an image to draw to it and then return it to the queue. How exactly the queue works and conditions for presenting an image from the queue depends on how the swap chain is set up. But general purpose of the swap chain is to synchronize the presentation image with the refresh rate of the screen. Hot fucking stuff, baby. So fucking sexy. Okay. Checking for swap chain support. Not all graphics cards are capable of presenting images directly to a screen for various reasons. For example, because they're designed for server and they don't have any display output. Secondly, since image presentation is heavily tied into the window system and surface associated with the window, it's not actually part of the Vulkan core. You have to enable VK swap chain device extension after querying it for support. For that purpose, we'll first extend the isSuitableDevice function to check if this extension is supported. We've previously seen how a list of extensions that are supported by VK physical device are doing that. Okay, so doing that should be fairly straightforward. Note that the VK header, previously nice micro, as is defined as the advantage of using this micro is that the compiler will catch misspelling. Okay. First, declare a list of required device extensions similar to the list of validation later to enable. Oh, fucking tits. How do I do my extensions? Do I do them differently? I think I do them correctly, no? So I query. Isn't the enumerator thing? Yeah, baby. I do it very, very similarly. Haha. So fucking hot. Sorry. Alright. So, in here, I just check the extension count. Alright. And this is... Okay. Modify the body of the function. Okay. So, extension count, which I do here. I do this. Okay. Available extension. Right. And then I do available extension. The data, which I do here. Available extension data. Okay. And then, ooh. Okay. And then, if the extension is, I see what he meant by spelling mistakes. Okay. Alright, well, yeah, another else state. And this fucking poem will just do a switch statement, to be honest with you. Switch. Can I do a switch here? No, I can't. I don't think I can, at least. Else if PK swap chain what's the fucking micro? VK HKR swap chain extension name. There we go. Are there more extensions? No. What? Fuck you. No, whatever. Alright, and the extension is I push them back. Instead of push, can we just do in place back, please? Thank you. Oh, push. Do I do that anywhere? So, I push back the extension name. I've chosen to use a set of strings here to present unconfirmed extension. That way you can easily pick them off while the routing sequence available for. Okay. Once is irrelevant, now we run the code and verify the graphics cards indeed. Tables without shades should be noted development presentation queue as checked. It should be noted that the availability of a presentation queue, as we checked in the previous chapter, so implies that the swap sharing session must be supported. However, good to be exploited about things. Okay, sure. Sure, my lovely. Sure, my baby. Alright, supported extensions. These are supported extensions. Okay. Um, we should exit here if we can find the ones we're looking for. Um, Okay, so here's the thing, right? We have this, and so we're saying that we compare the two strings together. If they're zero, it means we found this extension, we add it to the extensions list. So loop through all these. Found this add. We go here. Okay. I think I have to have another for loop, which I really don't want to, but I think I. Well, let's see. Hold on. Let me just try some code and figure out if that's correct or not. Let's size. Um. Actually, no. I just need to. If that size is bigger or equal to 3, cd out. Uh, Core extensions are okay, bool dk hkr when 32 press ext false. Equal to true. This fall off thing. Oh, sucks, but whatever. I have to do this line every single time. Okay. So we need a bunch of these. Go for 60. Okay. Blockchain. ext. Okay. And support for that. And support for this. And support for this. Okay. If that that did not find support for okay. That's the swap chain. On this. Why is this so much shorter? Oh fuck, something went wrong. Did not find support for a swap chain. Found support for that, found support for that. Oh, really? True. True. Oh, we never entered this. Okay. What are the extension names that I found? Okay, anything about swap chain color space? Yo, this is a fucking problem. Am I doing something wrong? It's supposed to be right. It's supposed to be the same thing what I'm doing right now. At least that's what I think. He's enumerating instance VK enumerate device. Device, not instance. PK device extension properties. There's two different ones. Are you fucking? Hmm. Okay, so we need to do it too. Lovely. Absolutely love that. Okay, so this is the physical. Once we find the physical device, where's the physical device? We create our instance. We create our surface. Then, oh, here. Enumerate VK physical devices. No, because we get our devices feature property. Where do we get our fucking physical device? Oh, here. Right, we find the physical device. Once we find the physical device, we need to query for this bullshit. Okay. All right. What is this for? Query physical device extensions. Okay. All right. We can do that. And oops, what did I do? Okay, we can do that. That shouldn't be a problem. All right, so we have our physical device extensions here. We need so basically all same thing. I need to remove this part and need to actually just comment this part out. You don't mind, Larry. Larry, you don't mind. You fucking mind. Alright, and also this. Okay. In here, we need to do and extension count. We're extension count. We can enumerate device and profit. Device. There. At fucking mention Count. Fuck the quality up top. And, oh, fuck that quality here. Extension count. There's two. Did I misspell something? No, I did not. This guy should give me an error. Which it did, because I declared it twice. No. Physical device extension. Yeah. Cool. So fucking find a bullshit. Does this return result? Of course it does. Alright, well, fucking bits. There we go. Uh, Vulkan extension, Vulkan physical device extension retrieval was successful. Failed to reach real Vulkan physical device extension. Alright, so once that is done, actually we make an STD vector. The fuck am I doing? STD vector with BK extension properties, and I code available extension with the physical extension. All right, Larry. That is beautiful. All right, so once we okay, so we're querying the device, physical device of all the extensions. We populate the vector, or we allocate enough memory for the vector to be happy. Once we do that, we do the same fucking thing again. But this time, we give it, this is the P over here, available. Whoa, calm down. Dot fucking data. All right. I don't like this. This is kind of disgusting, but you know what? That's how we like to do it, I guess. So we're retrieving the thing. If it fails, it tells us, hey, it failed, and successful. Which is all nice and dandy. Once we have our data, we'll see how our data looks like. Hold on. So put a breakpoint here, if you don't mind, senor. And let me check. 120 fucking extensions. Okay. 16-bit storage, 8-bit storage, extra blah, bind memory 2, buffer, copy, command, deferred, stencil. Holy mother of all that is mother. Okay, those are a lot of extensions. Those AMD shader, a lot of AMD shader stuff. VK Google HLSL functional. What the fuck? Google participates with the VK. Oh, I mean they have Android. They must write drivers for Android, right? For Vulkan. Yeah. Fancy. Alright, so we got a bunch of extensions. What do we do next? String extension device begin to end. This is amateur hour. Do this. Alright, get my lovely for loop size. It's I just I don't know if it's just me, but I hate for each loops. I don't understand why people like them. Please, the for loop has been around since C99. Why are we changing things up? Why? Why? Alright, I need to check if this thing equal to this is not JavaScript, dumbass. This is what it calls blockchain. What do we do with this? Where did we do this? Okay, so I have this variable over here with these lovely fellas. Over here with all of these lovely fellas. All the way down here. Alright, I would like this variable. Do I need the variable? I don't need the variable. I could need the variable. I don't know. We'll see. I need VK swap chain. So if I found it, then what do I do? What do I do? Oh, he's erasing everything. What do I exactly need if I found it? Do I need to enable the device extension? So create info. Where's the create info? Create info. Okay, so here, VK device create info. I need to pass in the extensions. So no, that's the queue. Is it the queue? No. Is it the queue? Shouldn't be the queue. No. No. Oh. It should be using swap chain requires enabling the VK swap chain extension first. Enabling extension just requires a small change in the logical device creation. Oh, it's the logical device creation. Well, excuse me. Why did you say so, good sir? Logical device creating for here we go. Hot stuff. Where the fuck did we do that? Oh, at the very bottom. Oh, wow. That's easy peasy. Alright, so what do we do with this? Once we provide the queues, put it before the queue. Logical device create info dot enable extension count equal to 0 for now. But whoa, what do they do? Okay. And then logical device create info dot enable names. Enable session names. Hold on, why is there two PVs? PP enable layer name. Okay, we don't want layer. Also 0. Okay. We'll get back to these in a second. For now, we want to check if this dot extension name is this even valid? STB cout counted. Alright, let's put a breakpoint, see if this ever triggers. The highly doubt it's gonna trigger. Maybe you have to do the string thing. Nope, don't care. Yeah, it didn't trigger. It did not trigger auto, so we're gonna have to do the whole C compare thing bullshit. C compare. Where the hell is C compare? Oh, here we go. Thank you. And we go all the way down. A little bit up. There we go. The extension name is that over here. This here. Apply here. Let's see if this works. There you go, baby. That works. Cool. Okay, so once we find it, we want to. I don't need this. What did I do up top? I made a extension names. Extension names. Where's the difference between what does this require anyways? Here. You need a const char const vk device create info. So const char const. What about you? What do you need? Const char const. Vk extension properties. So I can just make out of what is vk extension property? This is valid? I wonder. For breakpoint, yeah, let's see. Ooh, it's not happy. Not happy at all. VK instance create info. This const char const. And this is const char const. So the question here is, why does this work and not that? Oh, because I'm a fucking idiot. Duh. That's why. The way he did it, he just erases, and he has a string here. Enter and okay. Sure. Okay, so we kinda do this here, and then we push back the extension thing. This here. Copying some old code. Go all the way down here. All the way down here. Paste this over here. This would be physical device extensions or extension names. Physical device extension names. And place this over here, which I found. Available extensions. Available physical. Available physical. Available physical device extensions. Right. So we do that. I'd like you to be happy. And where was it here? Okay, fan support for VK swap chain. Fan support for VK swap chain. And then once we do that, just break out of it. Get out. Get out, get out, get out. Physical device extensions. We do that. Okay. I don't need this, or if physical device extensions dot signs less than or equal to 0. So you could not find support for request swap chain extension name. Not that. Not find support at every time we exit. Okay, cool. Delete all of this. Cool. And in here, all we have to do is say count size update. And there you go. Easy as butter, as they say. Okay. So, found a queue here. Welcome enters 2, total physical device found is 1. Physical device is good, graphics card, okay. Physical, okay. Found support for VK swap chain, nice. And then we added support for the swap chain. Alright, that's cool. That is, as they say, very cool. Alright, so once we did that, once we've done that, I just would like to make sure that this is actually correct. Give me a second. It's 1 swap chain. Oh, it's me. Alright, so we found support for the swap chain. Moving on with our lives. Alright, enabling swap chain, done that. Make sure to place the existing line. Enable extension count to 0. Ooh. Good point. Thank you for reminding me. That would have been very, very bad. That would have been really bad. Okay. Cool. Thank you. Bringing detail for swap chain support. Oh my god, it took us this long just to make this. Can't take us even longer to do this. Oh my god, look how much there is. Oh, Jesus Christ. Okay. Querying for swap chain support. Just checking if swap chain is available is not just motherfucker. Because it's not, it may not actually be compatible with our Windows Surface. Creating a swap chain also involves a lot more settings than instance and device creation, so we need to query for some more detail before we're able to proceed. There are basically 3 kinds of properties we need to check. Basic surface capability, minimum, maximum number of images in swap chain, minimum, maximum width and height of image, surface format, pixel format, color space, available presentation mode. Oh my fucking shit. Similar to find queue family, we'll use struct best DCL around. Once we've been queried, these 3 aforementioned types of properties come into form of the following struct. Okay. Formats, swap chain, support detail. Now we'll create a new function, query swap chain. This section covers how to query the struct. That includes this information, meaning the struct exactly. Okay. Alright. Format count. We need to pick the right format. Oh my god, they're so unbelievably, there's so much. Indentation mode, swap, extend. Oh. And then after all that, we create the swap chain. Retrieving the swap chain image. Oh my god. Oh my freaking shit. Alright, for this, I think we have to stop writing stuff in here. I think we need to move on. Like with the swap chain. Swap chain has to be moved somewhere. Like I can't have the swap chain also in here. That'd be disgusting. Like this class already is fucking disgusting. So much code in it. Okay. Alright, I mean, I think I'm gonna stop here, honestly, because this is good progress so far. And I physically cannot do this anymore. Like, it's been over half an hour. Been more than 40 minutes doing this. Since we started the swap chain. So, I think we'll continue. I mean, we created the swap chain. We created our device support swap chain, which is good. But now it's time to move on with our fucking lives. Alright? Alright, so here's what I'm gonna do. I'm gonna commit my code and do something else with my life. So, what do we do today? Vulkan will exit if, can I copy some code from here? If vk and okay, Vulkan will exit if vk surface and vkhr surface and this vk Vulkan will exit if vk surface hkr surface and swap chain is not or are not found. We read for vk swap chain. Not found, that's good. Did that. What is this thing we added? Added presentation view support. What else did we do? Honestly, I think that's it. That's all we did. We just added a presentation queue support, that's all. And it took us 2 hours. Or it took me 2 hours. Okay. Commit. Push it. TM, nice. Yesterday I streamed, 28th. Did a bunch of stuff. Today I streamed, 29th. And wait. Oh, because I stayed up until like 3 a.m. something like that. The 27th day was the 28th, and 29th is tomorrow. Well, technically today. Anyways, That's all great. I pushed the code. We're closing this. That's it for today. Tomorrow we'll continue. I'll do the swap chain tomorrow, hopefully. So I am going to skedaddle. I'll see you guys tomorrow.